Okay, instead of doing a commentary paper, I thought that my changes that I made to my instruction document would be better shown through doing a commentary video. So I just wanted to kind of go through my changes and how they are in line with the research that I did. So the old document that I had looked like this. It's called 6.1 polygons, as you see. The goals are handwritten, and the font changes from Arial to Times New Roman. The pictures are static. Um, they're actually just screen captures from the book. They do look pretty okay. You know, you can see that they have different colors, blue for sides, red for vertices. But I thought that I could do a better job of showing these relationships. You can see some of my pictures are hand drawn. It's not as consistent as I would like. Again, now I go from Times New Roman fonts to examples which are Arial fonts. So one of the major things I wanted to do was consistency, make sure that all my slides look the same, had the same fonts, and weren't kind of like, you know, ugly, I guess you could say. The other thing I wanted to do was to affect the diagrams, and that was what most of the research was. So instead of the diagrams being static, signal color, not different orientations, I chose to, instead of just giving one screen capture here, I wanted to separate the diagrams so that you can reorient them, separate them so that you can put different colors on them, and things like that. So this is the first instructional document. This is the one that I've been using for like three years now, and I'm in the process of revamping all my stuff. But this research is a little bit different than what I've been doing. So I thought that it was pretty cool the things that I could do with Smart Notebook. So again, here's the first one. Not very pretty, not very consistent. So what I did was I changed the font. It's all consistent now. It's all times, not Times New Roman, but Comic Sans. Pretty legible. I just made it consistent from one slide to the next. So what is a polygon? Okay, instead of having that screen capture from the book, I chose instead to kind of make the fonts all common and then color code things. So instead of having that picture that was just captured from the book, I chose to do an animation where the sides show up, they blink red, and you can see that sides are red here, sides are red there, and it kind of shows the relationships a little bit better, I think. The other thing is the vertices, and again, they show up, they blink, they show up blue like they are in the sentence. So color coding things, animating things, showing students diagrams in a different way, I think can really help them to see what the relationships are. All right, this one, instead of having all the diagrams as one screen capture, I chose to, individually capture them. Doing this, I can actually rotate them, give students a different orientation for them to look at. If they look at this one like, oh, that looks like an arrowhead or something. If they look at it from a different way, they might see a completely different shape. But the goal is to see that all of these have closed segment sides, so they are all polygons. So a little bit of animation there instead of just giving the answer, saying yes, these are, and no, these aren't. You can see that it's a little bit more fun for students to look at there. And then these two are not polygons because this one does not have segment sides and this one is not closed. So just giving students a little bit of a different look at the pictures, being able to orient the pictures differently is going to be very important. It's definitely something that's really cool with Smart Notebook that I have been trying to incorporate more. But now, since I looked at the research, it's definitely something that I'm doing all the time. All right, the names of polygon slide is basically the same. I just wanted to, again, keep it consistent with the other slides. You got Comic Sans font, so the fonts that tell you the major headings all look the same. Regular polygons, instead of the old one, which kind of look like this, all right, not as pretty, not as nice looking. I chose to, again, make some animations. You got the sides, they're going to blink red, and again, you can see that the sides were written in red, and then the sides blink red to kind of show the relationship between the word and the actual picture. And then the angles, again, blink blue because the angles were written blue. Just different things like that to keep it consistent, to keep it color-coded, to give students a little bit of animated picture so that they could possibly better see the relationships. In continuing on, convex versus concave, I added a little demonstration where the concave side goes away, the convex side comes up. So again, you got the blue for convex, and then the red for concave. You can see the relationships, so they can see the relationships a little bit better. And again, to compare that with what I did here, convex versus concave was just looking at pictures and saying this is convex and this one's concave, and just talking about it. But now they can actually see the relationships through an animation. All right, so the sum of the interior angles of a quadrilateral was the last thing that students wanted to get out of this section. Angles in a triangle add to 180, therefore we can find the angles in a quadrilateral. And again, I can show students through a little bit of an animation why this relationship is true. So because you can split a quadrilateral into two triangles like this, you know that its angles add to 360. And just showing them that little bit of an animation, showing them that a quadrilateral is literally just two triangles split, you know, together. Hopefully they can really see that relationship and they'll remember it a little bit better. The other thing is to show them these angles, a full rotation is 360 degrees. So I would show them this right here and say this is 360 degrees. But if they look at it in terms of the quadrilateral, they will surely be able to see that these relationships exist. So the angles in a quadrilateral, basically, and I just made up any old quadrilateral. The angles in a quadrilateral are going to add to 360 because if you pull them out like that, you can see that they make a full rotation. So showing students this relationship, you know, is something that we couldn't do before having smart notebooks. So again, it's just kind of using the technology to show animations, to show students a different way of looking at diagrams that they maybe didn't have in a previous class or previous books or things like that. And then the examples, I kind of just chose to streamline the look of it. I put two examples on a page rather than just one. I thought that would be better if we worked out one together as a class and then have the students work out the other one so that they can see the work that's still on the board. And I did this for a few of the examples to get some practice in. So those are the changes that I made. I think that they're aligned with the research that says color coding, orienting your diagrams differently, and animating diagrams to really help students perceive the diagrams in the way that they should. So again, the contrast is pretty significant. I think that the new file is definitely better for students as far as how they will then be able to perceive the diagram. Thank you, and I hope this explains the differences.